Okay, so welcome back. Anyway, we got this binary, so we can just go ahead and copy this and open up. I don't know. Let's go ahead and type in binary to text. Okay, so to text. Let's go ahead and paste it and press to text, and there you go. It's gonna give you the domain. Now, if I just delete one bit here, and if I click on to text, it says malformed binary or binary code must be divisible by 8 because it's using 8-bit encodings. Anyway, now that that is done, okay, so we no longer need this. Well, we can leave it. Maybe we'll use it for some demo purposes. Anyway, our next function is, it basically generates a list of candidate URLs. Okay, so it generates URLs, all of which that are by 1 bit different from this one. So if this is 0, here you will have 1 or something like that. If this is 1, then you will have a 0. If this is 1, 0, so 0, 1. And it generates all of those that are exactly 1 bit different from this one. So however many bits you have, that is how many different URLs you will have. However, not all of them will contain legal characters for the domain, so we'll need to do some cleanup work there as well. So let's take a look at this function. Okay. Anyway, generates a list of URLs. So it receives a string. It receives a type string, some string, and then that string is the domain. And then based upon, basically, it's the binary domain. It receives a binary string, so of ones and zeros. Well, I don't think that there's such a thing as a binary string, but you get the idea. The string only contains zeros and ones. The type binary string, I don't know, I'm pretty sure it doesn't exist. Anyway, this string that gets passed to this function as an argument, which will be used by this function, will be of zeros and ones. And this function will return an array list containing all the valid candidates, all the domains that are by 1 bit different. Okay, so we need an array list of type string. This will be a variable, and we're just going to go ahead and declare it here. And then we're going to go into a loop. So this is a bit of a shorter function here. We're not going to do anything special. Anyway, we're going to go into a loop. The loop will be the size of the loop, the length of the loop. The number of iterations in the loop will be basically the length of this string. So the amount of zeros and ones in this string. And we get that by typing in bindom.length. And then we're asking if the character within this string, so bindom.char at I, at position I, is equal to a char 0. Okay, if it is equal, so this is a comparison, this is not assignment, this is not equals, this is a comparison between this and between this. And here we have a char array, so if this is equal to 0, okay, go ahead and create a char array, cast the string bindom into a char array, create a temporary char, not create a temporary char, use the TMP char array at position I and assign 1 to it. Okay, so just assign 1 to it. And then go ahead and create a temporary string, so TMP str, well, it's not a temporary string, but that's how I named it, TMP string, and initialize that string to TMP char. And the contents of TMP char is basically just number 1 or character 1. Because it's not considered to be an integer here, it's just a character when you put it in like this. And then you go, then you use the array list candidates, and you say candidates add TMP str. Okay, so just add 1 to it. Simple as that, right? So let me just go over the logic one more time. If, for example, if here this is equal to 0, so this is equal to 0, it's going to go into this if statement here, and it's going to say, okay, convert the string bin dom to a char array, store it into the tmp char array, then modify the char array at position I and place 1. Replace whatever is at position I with 1. Then declare another string, which is tmpstr, and initialize it to this char array which has been modified. And then once that modification is done, please add it to candidates. So candidates.add and then tmpstr. The code down below is exactly the same. There are no differences, more or less, except the comparison is being made with 1 and you add a 0. So if it's 1, then replace 1 with a 0. After you are done, return candidates. Okay, so we can basically do this. Okay, since we no longer need to take a look at this function, we can just go ahead and do this. So candidates, Control C. I'm just going to go into the new line here, so you can see everything a little bit better. And I'm going to pass the return value of one function as the argument of this function. Okay, so let's save it and let's go ahead and run the code. Yeah, that's it, except it's a really, well, if you see you have an open bracket here, right? So if you just scroll a little bit, you'll see a comma. There you go. So there you go. There is a comma here. Okay, well, let me go ahead and do, we could basically do this. So just for, and I just want to create a bit of a better printout for you so you can see things a little bit better. So we're going to delete this code later because we're not going to need it, but I'm just doing this for demo purposes. So I is less than whatever the return value of this is, because this is going to return dot size. I'm just going to go ahead and put this into a new line so that you can see things better. Just going to put, and it's going to be I++, and then I'm going to go ahead and close it, but I am missing something. Okay. There we go. So classical for loop, no big deal, but we are going to go ahead and we're going to go ahead and do this because I've just split it into several lines. You can put, this usually goes into a single line, but I've placed it into several lines so that you can see it. If you put it into a single line, the code is exactly the same, except it's on the single line. And then I don't need any parentheses or anything like that since, okay, since there's only one statement, which is system.out.println, which I've broken into multiple lines. It's going to go into the for, and this is going to be printing out this. This is going to be creating this printout, but I don't want to repeat this printout for every line. Rather, instead, I want to take one element per line. So I'm just going to go ahead and state it's going to be get I. Oops, get I. Oh, the caps lock is turned on. Okay, so just get I, and I'm going to go ahead and save this, and then I'm going to go ahead and run it. And I mean, it's a little bit better because you get one domain per a line. So it is long, but you can translate all of these domains. As I said, just go online and go to binary to string, and you should be able to convert each one of these lines into a domain. Not all of these will be valid domains, but we have to clean them up. So let's go ahead and clean them up. This was the candidates, which generates a list of all possible candidates. And now we need to go into the third function here, which basically eliminates all the illegal characters. So what characters are not legal for domain names? Well, you cannot have a plus. You can have a dot at certain positions. You cannot have a comma, pipe, exclamation mark, quote, single quote mark, double quote mark, pound, dollar, percentage, and percent, slash, parentheses, greater than, lesser than, brackets, curly brackets, equals, question, caret, blah. Okay, you get the idea. So these are the characters which you cannot have in the domain name. Hopefully, dot you can have, but yeah, as I said, not at all positions, or it shouldn't be anyway, because it's not going to make much sense. The length of the domain can be anywhere between 3 and 63 characters. Cannot start with a dash. You can have a dash, but it cannot start with a dash, and it cannot end with a dash. It can have it in the middle. It can have dash in the middle. Legal chars for domain names. There are numbers, letters, and dash somewhere in the middle. You can also have dots. But there is a logic for the dots somewhere down below. I didn't actually put it here in the description. Okay, so this is like 2 times 26. That's how many letters are there. 10 numbers and 1 dash, and there is a dot. 2 times 26 letters, this is basically not true. This is actually just 26, not 2 times 26, because there are no lowercase and uppercase letters in the domains. I mean, there are, but lowercase and uppercase letters are treated exactly the same. It is the same domain, whether you use upper or lowercase letters, or that's how I think it is anyway. If I make some mistakes here along the way by stating something, feel free to contact me and to basically tell me, hey, Ermin, you're very much wrong here, and if you are right, I will, in all likelihood, apologize and create some sort of a fix. Okay, next up. Oh, but yeah, by the way, in regard to that, contacting me if I made some mistakes here, I'm not one of those people that's going to say, oh, what do you know, blah, blah, blah. I'll actually be very happy that you've taken the time to actually look at it and that you found a mistake. And if you found some mistakes, I'll be very happy to take a look at them, and I'll be very pleased that you have actually found them and informed me of it. Anyway, we're going to need 2 array lists. One will be txt dom, and the other one will be txt dom valid. So this is just text domains and text domains that are valid. So the first array list will be initialized to the return value of candidates dom. Candidates dom is the forward function here, which I have created. It's a bit of a bigger function. Well, not that big, but we're going to go over it. But this array list, so you have txt dom, it will be initialized with the return value of this function. So all the things that are returned by this function, the array list, that's what the array list down below will be initialized to. It basically converts from binary to text. That is the purpose of this method here. It just converts from binary to text. So we got the binary, we got all the valid candidates. We needed them to be in binary format because we needed only ones which are by 1 bit different. And now we need the text forms back again, so we can decide which ones are valid and which ones are not. So I just use this function, this method that I've written to basically convert this array list of binary domains back into text domains. And this array list here is pretty much empty. Okay, then we go down below and we begin replacing things within this domain. So we basically declare a string stripped and then use txt dom, which is already initialized to the text domains in the text format. And we basically say get I, so get the first one, then get the second one, and get all of them and check all of them. So iterate over all the domains with the iterator I. And then it says replace all, and here I have regex. So what this regex does is basically, okay, no matter what it begins with, find the range is between A and Z, lowercase, so between the lowercase A and Z, and then you have a different range which was between uppercase A and uppercase Z, and then you have another range which was between 0 and 9, and then you have a dash, and then you have a dot that I spoke of before. So that's the regex which we are employing here. So this is going to basically replace everything. So this will eliminate everything that is not a letter, a number, a dash, or a dot. So lowercase letters, uppercase letters, numbers, dash, and dot, everything that's not that will be eliminated. That's what this line does. And then it initializes the string stripped with the result of that. Next up, we use stripped lower string again, and we use stripped string from before, which has been deprived of any illegal characters, and then we convert everything to lowercase because it doesn't matter if it's uppercase, lowercase, so we just convert everything to lowercase. And then we basically have a bit of logic here. Again, with an if statement, it says if strip lower char at 0 is equal to dash, or if char at stripped lower dot length -1 is dash. So if the last character is dash, we're checking if the first character is dash or if the last character is dash. Because remember, I've told you that neither the first nor the last characters within the domain name can actually be dashes. So if this is the case, then just go ahead and if that is the case, or so we have another or here, or if the length of this string, so stripped to lower, which contains our domain name, is not equal to the domain name that's basically here at the same position from which the domain was taken, after it has been stripped of all the illegal characters, just go ahead and continue, because we do not need that domain. Obviously, if we have removed one of the characters, the length of this string and the length of this string will not be the same, because we have taken this string and we have we have searched it through. We've basically stated remove everything that is not this, and if something has been removed, then that is not a valid domain that we want to check, and therefore just go ahead and continue. It is not important to us. Else, use txt dom valid from here and populate it with stripped lower. So in that case, stripped lower is valid indeed. Nothing has been stripped from it. There wasn't a need to strip anything, and therefore just go ahead and add it to this array list. And then once you're done with all of that, go ahead and return to us txt dom valid. So return to us an array list of valid domains in a text format, which we are going to utilize later on. So approaching the time limit. See you in the follow-up where we will continue.